Okay, hello everyone. So this is the new Korad KWR103. Now, looking behind, if you notice, I've got some other Korad parts here, and I think in my last video I talked about their DC electronic loads. So anyway, I have not done a video in ages, and I wanted to do a quick one to talk about this power supply, so that people know, what you're looking for when you go and get it. This isn't a sponsored video. Korad definitely doesn't pay me to do this. I just talk about these things, and they have ups and downs and everything. So, just give you a quick once over the front of the instrument. It's very, very similar to over here. You can see this is the KA60, so it's a 60 volt 3 amp power supply. Very good, very reliable. Very similar interface. They basically just kind of rearranged it and then added some other features. So, let's talk about specifications. With these kind of power supplies, the two things you care about generally are the voltage and the current. Now, one of the things that they explicitly specify up here, which they do not do on other power supplies, is the wattage that they're capable of. Now, this means that this is a 300 watt power supply, which means the max wattage that you're going to get out of it is 300 watts. So you're not going to get 60 volts at 15 amps. That would be a lot of power. So just keep that in mind when you're looking at this power supply. To not get carried away with the fact that this is 60 volt 3 amps. Now, if you want, 1 volt at 15 amps, you're great. Like, that stuff's going to happen. The lower voltage, high amperage stuff is going to happen. So how do these power supplies function? How are they able to deliver such a great dynamic range? Well, they're hybrid in the sense that, and I believe this, I took the screws out, but I haven't opened it yet. It's a DC to DC with a linear stage afterwards, which allows you to get the accuracy and the cleaner, current out of it. So I'm pretty sure that that's how they're doing it. So their linear stage only has to burn off, maybe 1 volt or not very much. So just a quick user guide. VSet, you set the voltage. You use the button to. Oh, never mind. Well, you used to press the button to index through this, index through the digits. I don't know how to do that now, but we're not going to explore that in this video. And then here you can change the current up to oh, okay, so they limit it in here for you, so that's really cool. So I guess if we increase the voltage, that's the highest voltage we can get with that current. Oh, that's really neat. Okay, so they do that. Sometimes I've had power supplies that will not do that for you intelligently, and they'll just get clunky about it. Okay, so without further ado, we're going to connect this thing up. Again, I'm just trying to keep this video a one shot. I won't do any editing or clipping in between, just because that stuff takes a lot of time. It's not my favorite thing to do. So what I'm going to do first is I'm just going to connect this to just this 5.5 digit multimeter. So most power supplies that are in this price range, usually you can expect them to be about plus or minus 10 millivolts. Is also usually what the manufacturer will specify them out to be. If you want 1 millivolt accuracy from a linear power supply, you do pay a lot more for that. And at that point, you might want to just look at getting a source measure unit instead of a power supply. Okay, so the other nice thing is it has an on-off button. The only thing that I don't like is that this isn't an obvious button. If this was surrounded in red or something, that'd be awesome, because you want to be careful when you're hitting that. So I'm going to set the range of the voltmeter, and what I'll do is I'll zoom out here so you guys can see that. My bench is a total mess. Okay, so we've got our meter up here, and then the power supply here. We're going to turn it on. So you can see we've got 60 volts. So that might look like, oh, like absolutely fantastic accuracy, but there's probably 10 millivolts of error there. What we'll do is we'll go down, look through it, see if there's okay, just a quick sweep so you guys can see what, and keep in mind we have no load right now. Turn this on, we'll do a demo there in a second. Yeah, so it looks pretty good. I wish I could change the digits. Sherm could just look up a manual right now, but okay, so that seems to work pretty well. What we'll do is we'll go down on the range just to see the what the accuracy on the lower digits looks like. Pretty accurate, actually. But again, Even though you're only seeing plus or minus 1 millivolt here, I do not expect this power supply to keep that up when we put it under load. If it does, that's really cool, and for a $300 power supply, you should definitely get one. Whoops, you should definitely get one. Okay, so the other thing I'm going to do is we're also going to do, we're going to look at this is connected to the oscilloscope, so we're just going to do a waveform capture when we enable it and when we apply a load to see if there's any overshoot or any instability in the power supply. What we'll do at the end of this video, I should have said this at the beginning, we'll also take a quick look inside, as well as I'll show you what's on the back of the power supply. I wanted to start with this stuff. Alright, so what I'll do to start is I'll set this just at 5 volts. I'm sure a lot of people will use it at 5 volts. And the scope, I'll move up. This scope, the Rigol 5000 series, don't buy them. The display is so bad. If you want a scope with this capabilities, maybe get a USB scope or something. This display is dreadful. Okay, so we'll set our trigger somewhere there, and we'll turn our load source on and off. Okay, so that's pretty good. So I'll zoom in on that so you guys can see that. Again, we're not under any load here. Whoops. Sorry. We're not under any load here. Yeah, that's yeah, not bad. There's no overshoot. That ramp up is I don't know, that's about 50 milliseconds. Like, that's perfectly fine. One of the things you'll notice, or maybe you've already noticed this about turning this relay on and off, is there's no relay click. I don't think there's a relay in here, which is pretty interesting, which means it's just electronically controlled. There's some upsides and downsides to that. Not having a relay means that you're less likely to have overshoot in the output, but there may be some protection issues. If you reverse voltage this thing and it doesn't pick it up, you could destroy whatever that front end is. But I don't know. I haven't looked into it in that detail. Okay, so what I'm going to do now is I'm just going to take these other 2 leads, and we're going to go up here, and we're going to apply some load to this thing. Now, this is kind of a silly way of evaluating a manufacturer if you're testing their power supplies against their loads, because that's probably what they're doing. Keep in mind that the readout on this is usually not very accurate. So we've got our voltage from the supply here, and this, and then we're also going to have the readout here. I'm not going to read the current out here, but the current reading on this is usually pretty accurate. Okay, so we'll just turn this load on. So that's at 100 milliamps. So there you can see, at 100 milliamps our accuracy's gone. So it's not 1 millivolt. Indeed, it is probably 10 millivolts. I didn't actually look at the spec for this, so it could be less. We'll go to 1 amp. So these test leads are rated, I think, for about 10 amps. So the most I'm going to put through in this test is 10 amps. So now you can see that we're off by 50 millivolts. Maybe the spec is plus or minus 100 millivolts. I don't know again. So we'll go to 5 amps. So now we're taking 20 watts through it. Okay, so the accuracy has really dropped off. Again, ignore this number. This is usually very wrong. And you could trim that value out. If you are always connected like this, you could trim it out. But if you're expecting a continuous 5 volts at whatever the power level that you want is, you're not going to get it. So let's turn up the available current. We'll just put it all the way up. And we'll do 10 amps. Again, the most we can really put through this cable. Okay, so at 10 amps it seems to be pretty good. What we'll do is we'll quickly put, whoops, how do you cancel on this thing? It's off, enter. Okay, so we'll do 15 amps just for a short period of time. Okay, and at 15 amps, even though this was set to 15.5, we clearly overdrew it. So now what we'll do is we'll do that once more. I don't want to sweep the whole thing, but we'll go up to, we'll take this up to our 60 volt range and test it up there. So we'll turn our I set down, and then our V set will go up to 60 volts. Okay, and then we're going to turn our output on. Our load is still on. So you can see here's our 60 volts, and we'll take 60. So we'll take 5 amps from this. Yeah, not bad. Again, 300 millivolts of error. Seems to be the exact same offset. Maybe we'll try 30 volts now. You can hear the power supply humming. You can hear it working hard, whatever that is. So I guess the other thing that we want to check now is we want to see now if there is some overshoot. So we'll change the range of the scope. We'll do this at 35 volts instead. And we'll set our trigger here. And we're going to turn it off here and back on. Okay, I'm not sure why it didn't trigger. Oh, sorry. So we're turning it off. And I'll turn it on again. Okay, so if you're looking up at the scope there, you can see that we have a nice we have a nice flat curve. There's no overshoot at all. So when you turn it on under a 5 amp load, there's no overshoot, and I probably would expect that performance to occur all the way through. Okay, so let's just take a look at noise while it's under load. I'm so sorry about this camera work. Okay, so change our mode. So we're just going to AC couple this and set our trigger to 0. Go up on the amplitude. So there you can see this is the ripple you'd expect from that might be the 60 hertz actually. Okay, so you know, like about kind of 50 millivolts of noise when it's under a load like this, and if we turn that load off, it stays about the same. Yeah, I don't know enough about what's going on here inside of here to comment on that. Okay, so yeah, so this is a pretty good power supply for the money. And at the end, I'll give you my final thoughts on this. So what we'll do now is we will loads off, current draws off on this. We'll take a look at it, unplug it. I took the screws out already, so you don't have to wait around for that. Okay, so again, front panel we kind of went over already. It's not that warm. We didn't really test it that much. On the back panel, so we have sense and trigger stuff. That's really nice. So what happens here, and you can have also these outputs for higher current, because through these BNC cables, I don't think it's probably 10 amps. The BNC connector may be rated for more, but the cable's usually only 10 amps. So if you want to run the higher currents, especially on the 30 amp version of this, you want to do it through the back terminals. It has RS485 as well as they left RS232 on it. Don't know why. And then it has USB and LAN. And the LAN is the reason that I bought this. And you can switch it between 120 and 240, which is really nice. And then, so I'm assuming that the Sense Plus and Minus, you may be able to get some additional accuracy out of it if you're using those terminals at your load, so that you don't have drop across your cables and stuff like that. But I'm not sure. I have to look up what that's for, but that's what I would expect. All right, let's take a look at the inside of this thing. Okay, I'm not going to take the whole thing apart because it's a lot of screws and I want to use this. Power PCB, lots and lots of heat sinks, and another power PCB. So it looks like, we'll just do a quick analysis of this thing. It looks like the AC comes straight in onto this board. On this board, looking across it, so there's no big transformer in here. This weighs less than the other Korad power supplies. So you can see the DC to DC on the inside there, and then it comes back to that other board on the bottom. This other board, this is the bottom board, which is connected to all these heat sinks, has these Probably linear regulators on them. You could look up the part number of this big guy, MN1526. So it is. Yeah, that's the construction. Oh yeah, down here, there's a digital board. It's clearly got an STM32 on it. The JTAG header's broken out as well. So if someone wanted, they could probably do some modifications on this power supply to do some custom stuff. So, who needs this thing? Do people need this thing? Is this useful in your lab, in your bench, as a hobbyist? So, let's bring this guy out as a reference. So we'll just, compare apples to apples here. We'll talk about two different Korad supplies. This is phenomenal. It's great for its price, and if you don't need the programmability, you can buy the non-programmable ones even cheaper. It's very stable, it's very accurate. I've beaten this thing up. It has seen a lot of weird stuff, and it's still going. I've also used these. I help startups set up their electronics labs, and I often recommend these. And I've had them break them and blow them up before, and I've been able to repair them. So I can, if this has blown up regulators or whatever's dead inside of it, it can usually fix it in 20 minutes. It doesn't take long. Easy to take apart, easy to service. So this thing, I don't know about longevity. Just got it. I'm not too sure. So we saw that there were some accuracy issues at higher currents. I don't know if I'd call those issues. That's kind of expected. It's nice that it's accurate at lower currents, so if you are just using it as a source for an op-amp or something like that, you can expect a bit of accuracy out of this. So who needs this? I would say people working with motors and batteries would get this. If you're working with a lot of analog stuff or general embedded systems, this may be a better option. Now, a lot of embedded systems development is actually transitioning to kind of above that 3 amp range. Now, this power supply also comes in a 30 volt 5 amp and 10 amp models, which would be very well suited for embedded development because of that capability to handle high current at 5 and 12 volts. So this is, if you're doing battery development, you're working on battery charge systems, or you want to use this as part of a battery simulator, which I talked about in my last video a little bit, this is a really good option, especially if you're working with motors. Now, I don't know how it's going to deal, or how well it's going to do with a lot of back EMF or connected to a power supply that may have current coming out the other end, connected to a load that could feed into this. Oh yeah, they tell you right there, max 10 amps. It does have the 300 watt limit, so you are only going to drive loads that big, but this would definitely let you create a battery simulator to test a lot of different things. Do I think this power supply is worth it for the price based on the test that we just saw? Absolutely, I think it is for $300, but I don't think that many people would need this. If I didn't need 300 watts, I wouldn't buy this. I would get this one because it's the exact same functionality, other than that this has Ethernet. But this is going to give slightly better output performance as far as stability and noise goes. So that's my 10 cents. I hope that kind of informed your decision. Oh, one more thing. This power supply, I'll move my camera, is longer. It's thinner, but it's longer. So if you have like a bench that's on like the L shelves, like just on your wall, like if you're like a home hobbyist, this one is going to fit a lot better, and you're going to have room for the cable. This one might stick out a mile. It's thin, but it's really, really long. So yeah, that's take that for what it's worth. Yeah, so I guess the last thing is that if you're trying to decide between this, maybe the Siglent power supply or the Rigol power supplies that are in this series, I would honestly still pick these. The Rigol and the Siglent displays, the Rigol and the Siglent devices are very attractive because they have LCDs on them. These do not have LCDs. These do not have like full, color LCDs. But they do, these LCDs are excellent. They don't fail. You can see this one's probably been dropped a couple times. The user interface is fantastic on these. As soon as you know it, it makes perfect sense. the user, I have the Rigol one as well, and I hate it. The user interface is absolutely dreadful. The Siglent interface is really good, and that is a good power supply, but you pay a lot more for it. For 2 channels, I think it's $500, and you don't get this current rating. So yeah, so you know, final words. If you are doing just general analog development and microcontroller stuff, get this. If you're doing motors or heavy FPGA stuff, maybe, or embedded system development using maybe IMX8 processors or any of the new higher powered Rockchip processors, this is a good choice. So yeah, hope this was informative. Thanks.